We'll start in 1 minute. Today we'll review for test 3. Test 3 is tomorrow, starting a few minutes before 8 o'clock. Okay, the first one, we'll just do part A for now, and then if there's time, we'll come back and do part B later. Find the restricted values for each rational expression, and then solve each equation. For this one, the restricted values are 4 and positive 1. Positive 4 and positive 1 are the restricted values. The least common denominator is x minus 4 times x minus 1, which is the same as x squared minus 5x plus 4. So we clear the denominators, multiply every term on both sides by the least common denominator. So on the left-hand side, multiply by x minus 4 times x minus 1. And then I'll write the denominator in factored form. Instead of x squared minus 5x plus 4, we can write x minus 4 times x minus 1. And then multiply the next term by the least common denominator. And also on the right-hand side, multiply by the least common denominator. Okay, the reason we do this is so we can clear the denominators. Over here, x minus 4 divided by x minus 4, x minus 1 divided by x minus 1. So we're just left with x minus 10. And then the next term, x minus 4 divided by x minus 4 cancels. So we have x minus 1 times 6. On the right-hand side of the equation, x minus 1 divided by x minus 1, those cancel. And we're left with x minus 4 times 3. And then we just solve the resulting equation, x minus 10 plus 6x minus 6. On the right-hand side, x minus 4 times 3 is 3x minus 12. Combine like terms on the left-hand side, we have 7x minus 16 equals 3x minus 12. And the next step, I'll do a couple of things at once. Subtract 3x from both sides and add 16 to both sides. So we'll get 4x equals 4. Then divide both sides by 4, we get x equals 1. But x equals 1 is restricted, so that means there's no solution. Okay, let's work on the word problems. The first one, Ralph takes 3 hours to put in a slab of concrete. If Don helps, it takes them 2 hours to do the job when they work together. Find how long it would take Don to do the job by himself. Okay, so for Ralph, Ralph's rate times 3 hours equals 1. It's a work problem, so equations have the form rate times time equals 1. We're supposed to find how long it takes Don by himself. So we'll use T to represent the amount of time it takes Don by himself. But when they work together, they can do the job in 2 hours. So Ralph's rate plus Don's rate times 2 equals 1. Then Ralph's rate is 1/3 of the job per hour. Don's rate is represented by 1 over T. And then when they work together, Ralph's rate plus Don's rate, they can do 1/2 of the job per hour. So the rate is 1/2. Okay, so we, in this equation, replace Ralph's rate with 1/3 plus Don's rate, which is 1 over T, equals 1/2. And then solve this equation for T. The least common denominator is 6T. So multiply every term on both sides of this equation by 6T. So 6T over 1 times 1/3 plus 6T over 1 times 1 over T. And then on the right-hand side, 6T over 1 times 1/2. And then here, 6T divided by 3 is 2T. So 2T. And then 6T over 1 times 1 over T, the T's cancel, so we get plus 6. And on the right-hand side, 6T over 1 times 1/2 is 3T. And then to solve for T, we just subtract 2T from both sides, and we get T equals 6. So it takes Don 6 hours to do the job by himself. All right, in the next problem, Nate walked 12 miles uphill and then walked back the 12 miles downhill. He walked 2 miles per hour faster going downhill than uphill. The walk uphill took 1 hour longer than the walk downhill. Find how fast Nate walked uphill. So this is a uniform motion problem. Equations have the form rate times time equals distance. So the uphill rate, we're supposed to find the uphill rate. So let's use x, miles per hour. The downhill rate was faster by 2 miles per hour. So going downhill, x plus 2 is the rate, x plus 2 miles per hour. And then we can write equations. Uphill, the rate, x times t sub u, that represents the amount of time it took to go 12 miles uphill. And then downhill, x plus 2 times t sub d, that's the amount of time it took to go 12 miles downhill. And we're told that the walk uphill took 1 hour longer than the walk downhill. So that means the time t sub u is greater than the time t sub d by 1 hour. So we can get an equation out of this. The larger number, t sub u, minus the smaller number, t sub d, equals 1. Okay, so solve this equation for time. T sub u is 12 over x. Solve this equation for time. T sub d is 12 over x plus 2. And then in this equation, replace t sub u with 12 over x, and we're subtracting t sub d, which is 12 over x plus 2, and that equals 1. So in other words, 12 over x minus 12 over x plus 2 equals 1. The least common denominator is x times x plus 2. When we multiply the least common denominator by 12 over x, the x's will cancel, so we'll just be left with 12 times x plus 2. And then minus 12 over x plus 2 times x plus 2. This time the x plus 2 factors cancel, so we'll get minus 12x. And then we multiply the right-hand side by the least common denominator, and we don't get any cancellations. We get x times x plus 2, which is x squared plus 2x. And then we just solve this equation for x. So here we have 12x plus 24 minus 12x equals x squared plus 2x. Notice on the left-hand side simplifies to 24. So when we subtract 24 from both sides, we get 0 equals x squared plus 2x minus 24. And we can easily solve this equation by factoring. The left-hand side is 0. The right-hand side in factored form is x plus 6 times x minus 4. One of the solutions is negative 6. That can't be the answer. The other solution, positive, x equals 4. So the rate going uphill is 4 miles per hour. Okay, let's move on to the next page. Solve the rational inequalities. Write solutions in algebraic and interval notation. Okay, the right-hand side is 0, and so the endpoints are the numbers that make the numerator 0 combined with the numbers that make the denominator 0. So the endpoints are x equals -1 and x equals 5. We plot those numbers on the number line, -1 and 5. So we have 3 separate intervals. So in the first interval, pick a number less than -1, like -2, and then in the inequality, replace x with -2. In the numerator, -2 plus 1 is -1. In the denominator, -2 minus 5 is -7. This is positive 1/7, but the inequality is less than or equal to 0. And this is false. So none of the numbers from -infinity to -1 are solutions. In the second interval, we can pick 0 as the test point. And then in the inequality, replace every x with 0. So we get 0 plus 1 in the numerator, 0 minus 5 in the denominator. That is -1/5. The inequality is less than or equal to 0, which is true. So all of the numbers between -1 and 5 are solutions. And then in the third interval, pick a number greater than 5, like x equals 6. In the inequality, replace every x with 6. In the numerator, 6 plus 1 is 7. In the denominator, 6 minus 5 is 1. So +7 less than or equal to 0 is false. So none of the numbers from 5 to infinity are solutions. Remember, endpoints that come from the denominator are never, ever included in the solution set because division by 0 is undefined. So we exclude 5, but the other endpoint if we replace every x with -1, we'll end up with 0 less than or equal to 0, which is true. So this time we include 1. And so the algebraic notation is -1 is less than or equal to x, which is less than 5. That's the algebraic notation. The integral notation is bracket -1, comma 5 parenthesis. Notice that the next inequality, the left-hand side is the same as the previous example, but this time it's greater than or equal. So we won't go through the whole process. I'll just point out what's going to happen for each of the 3 intervals. Since the inequality is reversed, this time it will become yes, no, yes. So the algebraic notation, well, first, -1 is included and 5 is excluded. And so the algebraic notation, x is less than or equal to -1 or x is greater than 5. That's the algebraic notation. The integral notation is parenthesis -infinity, comma -1 bracket union, and then parenthesis 5 comma infinity parenthesis. For now, let's bypass this one. I'll just do one thing here. I'll factor the denominator, x squared plus x minus 2. The two factors are x plus 2 and x minus 1. And I'll identify what the endpoints are. The endpoint from the numerator is +3. One of the endpoints from the denominator is -2. And the other endpoint from the denominator is x equals +1. So in this one, the endpoints -2 and 1 are not included in the solution set. But since the inequality is less than or equal to 0, the endpoint 3 is included. But test the 4 intervals in the same way. Okay, let's move on to the next section, simplifying roots and radicals. So in part A, simplify the square root of 121 times x to the 22nd. We can simplify this directly because 121 is a perfect square, and so is x to the 22nd. The square root of 121 is 11, and the square root of x to the 22nd is x to the 11th, because the exponent 22 divided by the index 2 is 11. Okay, the next one, the cubed root of -216 plus the 5th root of 32. Those can be simplified directly because -216 is a perfect cube, and 32 is a perfect 5th power. The cubed root of -216 is -6, and the 5th root of 32 is 2. And we can simplify further because -6 plus 2 is -4. Okay, in the next example, the 4th root of 81 minus the square root of 81. The 4th root of 81 is 3. And the square root of 81 is 9. And then 3 minus 9 is -6. The next one, the square root of 144 x to the 8th, y to the 12th. This can be simplified in one step because 144 is a perfect square, and so are x to the 8th and y to the 12th. The square root of 144 is 12. The square root of x to the 8th is x to the 4th. And the square root of y to the 12th is y to the 6th. Okay, the next example is a little more involved. The square root of 125 m to the 23rd. The largest factor of 125 that's a perfect square is 25. The largest factor of m to the 23rd that's a perfect square is m to the 22nd. So we'll rewrite this as the square root of 25m to the 22nd times the square root of 5m. And then we simplify the square roots of the perfect squares. Square root of 25 is 5. Square root of m to the 22nd is m to the 11th. And then we must multiply that by the square root of 5m. That's the simplified answer. Okay, on the next one, we have the square root of 98x to the 25th over 72y to the 18th. Notice that 98 over 72, that can be written in lower terms because 98 and 72 have a common factor of 2. So let's rewrite this as 49, the square root of 49x to the 25th over the square root of 36y to the 18th. And then write it as the square root of 49. We'll do part of the work. X to the 25th is not a perfect square. The largest factor of x to the 25th that is a perfect square is x to the 24th. So in the numerator, we'll write the square root of 49 times x to the 24th times the square root of x. And then in the denominator, we have the square root of 36 times y to the 18th. And then in the next step, we can write the simplified answer. The square root of 49 is 7. The square root of x to the 24th is x to the 12th. And then we multiply that by the square root of x. And in the denominator, the square root of 36 is 6. And the square root of y to the 18th is y to the 9th. This is our simplified answer. In the next one, the cubed root of 16m to the 24th over 250n to the 30th. Notice that 16 over 250 reduces to 8 over 125. So this is the cubed root of 8m to the 24th over 125n to the 30th. Every one of the factors in both the numerator and denominator are perfect cubes. So we can simplify this directly. In the numerator, the cubed root of 8 is 2. And the cubed root of m to the 24th is m to the 24 divided by 3, or m to the 8th. In the denominator, the cubed root of 125 is 5. And the cubed root of n to the 30th is n to the 10th, because the exponent 30 divided by the index 3 is 10. Okay, moving on, section 8.3, simplifying rational exponents. 64 raised to the 3 halves. So that's an exponent, 3 halves. So we can write this as 64 to the 1 half raised to the 3rd. And then 64 to the 1 half that's the square root of 64, which is 8. And then we have 8 to the 3rd. And 8 to the 3rd, 8 times 8 is 64, and then 64 times 8 is 512. So with a calculator, you can easily compute that. The next one, the number negative 64 in parentheses raised to the 2/3 power. So we have, if we rewrite it as negative 64 to the 1/3 and then to the second, the number negative 64 to the 1/3 is negative 4, because negative 4 to the third is negative 64. So this is negative 4 to the second. And then negative 4 to the second is negative 4 times negative 4, which is positive 16. In the next one, 6 to the 5/2 times 6 to the 1/2. Since the base number 6 is the same in both and we're multiplying, we can write 6 to the 5/2 plus 1/2. The exponent 5/2 plus 1/2 is 6/2, and 6/2 is 3, so we get 6 to the third, and we can evaluate that. 6 to the third, 6 times 6 times 6 is 216. Okay, in part D, 32 to the 3/5 in the numerator divided by 16 to the 3/2 in the denominator. So the numerator, we can write this as 32 to the 1/5 to the third, and in the denominator, 16 to the 3/2, we can write this as 16 to the 1/2 to the third. And in the numerator, 32 to the 1/5 is 2. So this becomes 2 to the third in the numerator. And in the denominator, 16 to the 1/2 is the square root of 16, which is 4. So we get 4 to the third. And we can take it further. In the numerator, 2 to the third is 2 times 2 times 2, which is 8. In the denominator, 4 to the third, 4 times 4 times 4 is 64. And we can simplify 8 over 64. 8 goes into 8 once, and 8 goes into 64 8 times. So our simplified answer is 1/8. Okay, let's move on to the next page. Add, subtract, and multiply radical expressions. So here we're subtracting and adding, but first we need to simplify the radicals. So the square root of 72y to the 5th, the largest factor of 72, that's a perfect square, is 36. The largest factor of y to the 5th, that's a perfect square, is y to the 4th. So we'll rewrite that as the square root of 36y to the 4th times the square root of 2y. And then we're subtracting the square root of 50y to the 5th. The largest factor of 50, that's a perfect square, is 25. And the largest factor of y to the 5th, that's a perfect square, is y to the 4th. So we replace the minus square root of 50y to the 5th by minus the square root of 25y to the 4th times the square root of 2y. And then plus the square root of 98y to the 5th. The largest factor of 98, that's a perfect square, is 49. 49 times 2 is 98. And then y to the 4th is the largest factor of y to the 5th, that's a perfect square. So we rewrite this as the square root of 49y to the 4th times the square root of 2y. And then simplify. The square root of 36 is 6. The square root of y to the 4th is y to the 2nd. So 6y to the 2nd times the square root of 2y. And then minus the square root of 25y to the 4th times the square root of 2y is minus 5y to the 2nd times the square root of 2y. And then plus the square root of 49y to the 4th times the square root of 2y is 7 times y to the 2nd times the square root of 2y. All three terms are like terms. They have the same radical, the square root of 2y. They also have the same variable part on the outside, y to the second. So 6 of those minus 5 of the same plus 7 leaves us with a total of 8 y to the second times the square root of 2y. In the next example, well, up here in this space above, we'll simplify this one. The fourth root of 48 r to the 10th plus the fourth root of 243 r to the 10th minus the fourth root of 3 r to the 10th. Okay, the largest fourth power factor of 48 is 16 because 2 to the fourth is 16. And the largest largest factor of r to the 10th, that's a perfect fourth power, is r to the 8th. So we'll rewrite this as the fourth root of 16r to the 8th times the fourth root of 3r to the second. And then the largest factor of 243, that's a perfect fourth power, is 81, because 3 to the fourth is 81. 81 times 3 is 243, and the largest factor of r to the 10th, that's a perfect fourth power, is r to the 8th. So we'll rewrite this as the fourth root of 81 times r to the 8th times the fourth root of 3r to the second. And then we're subtracting the fourth root of 3r to the 10th. So the 3 has to stay inside, but the largest factor of r to the 10th, that's a perfect fourth power, is r to the 8th. So this is minus the fourth root of r to the 8th times the fourth root of 3r to the second. Okay, then simplify the fourth root of 16r to the 8th. The fourth root of 16 is 2. And the fourth root of r to the 8th is r to the second, because 8 divided by 4 is 2. So 2r to the second times the fourth root of 3r to the second. The fourth root of 81 is 3. The fourth root of r to the 8th is r to the second. So 3r to the second times the fourth root of 3r to the second. And then minus the fourth root of r to the 8th is r to the second times the fourth root of 3r to the second. All three terms are like terms. They have the same exact radicals, but also the same variable parts on the outside. So we have 2 times all of that plus 3 times the same minus 1. So when we combine those, 2 plus 3 is 5, 5 minus 1 is 4. So our final answer for this one is 4 times r to the second times the fourth root of 3r to the second. Okay, the next one, we're multiplying 2 square roots. The square root of 5x to the 13th, y to the 5th, times the square root of 80x to the 7th, y to the 11th. So my advice, since we're multiplying 2 square roots, is just to write it as 1 square root by multiplying the radicands. So inside the single square root, we'll have 5 times 80, which is 400. X to the 13th times x to the 7th, which is x to the 20th. We're adding the exponents, 13 plus 7. And then y to the 5th times y to the 11th is y to the 5 plus 11, or y to the 16th. Inside the square root, each one of those factors is a perfect square. The square root of 400 is 20. The square root of x to the 20th is x to the 10th. And the square root of y to the 16th is y to the 8th. In the next example, we're multiplying a couple of terms that resemble binomials. So 6 times the square root of 5 minus the square root of 7, we're multiplying that quantity by the square root of 5 plus 2 times the square root of 7. So we start multiply 6 times the square root of 5 times the square root of 5, and then plus 6 times the square root of 5 times 2 times the square root of 7, and then minus the square root of 7 times the square root of 5, and then minus 2 times the square root of 7 times the square root of 7. Okay, so 6 times the square root of 5 times the square root of 5 is 6 times the square root of 25, because 5 times 5 is 25. And then 6 times the square root of 5 times 2 times the square root of 7 is 12 times the square root of 35. And then minus the square root of 35, because 7 times 5 is 35. And then minus 2 times the square root of 49. The square root of 25 is 5, so this becomes 6 times 5. We can combine the two middle terms because they are like radicals. 12 times the square root of 35 minus the square root of 35 is plus 11 times the square root of 35. And then we have minus 2 times 7 because the square root of 49 is 7. So we can simplify further. 6 times 5 is 30. Then we're going to subtract 14 from it. 30 minus 14 is 16. So our simplified answer is 16 plus 11 times the square root of 35. So that cannot be simplified any further. Okay, the next one, divide the radical expressions. So that means we want to rationalize the denominators. So 7 divided by 5 plus the square root of 2, we're going to multiply 7 times 5 plus the square root of 2 by 1 in the form 5 minus the square root of 2 over 5 minus the square root of 2. We're just multiplying by 1. So in the numerator, 7 times 5 minus the square root of 2 is 35 minus 7 times the square root of 2. And in the denominator, 5 times 5 is 25, and then minus 5 times the square root of 2, and then plus 5 times the square root of 2, and then minus the square root of 2 times the square root of 2. So the numerator will stay the way it is momentarily, at least 35 minus 7 times the square root of 2. And in the denominator, notice that the two middle terms add up to 0. Minus 5 times the square root of 2 plus 5 times the square root of 2, those add up to 0. And then we have 25 minus the square root of 4. I'll go ahead and write it. It's 25 minus 2 because the square root of 4 is 2. And then just one more step, 35 minus 7 times the square root of 2 divided by 23. So we rationalize the denominator. Okay, the next one is the same sort of process. We're going to multiply the numerator and denominator by the same. In other words, we're going to multiply by 1. This time the form 1 takes is the square root of x plus the square root of 7 over the square root of x plus the square root of 7. Okay, in the numerator, we'll get the square root of 13x, because the square root of 13 times the square root of x is the square root of 13x. and then plus the square root of 91, because 13 times 7 is 91. And in the denominator, the square root of x times the square root of x is the square root of x squared. And then we have plus the square root of x times the square root of 7, which is plus the square root of 7x. And then minus the square root of 7 times the square root of x, which is minus the square root of 7x. And then minus the square root of 7 times 7 is 49. Okay, the numerator can't be simplified further, so we have the square root of 13x plus the square root of 91. And in the denominator, the square root of x squared is x. The two middle terms add up to 0, and then we just have minus 7 because the square root of 49 is 7. So that is our simplified answer. Okay, for the next one, 7 divided by the fourth root of 5. So this time we multiply by 1 in the form, the fourth root of 5 to the third divided by the fourth root of 5 to the third. We're choosing this because 5 times 5 to the third is 5 to the fourth, which is a perfect fourth power. And so the numerator becomes 7 times the fourth root. And instead of writing 5 to the third is 5 times 5 times 5, which is 125. So in the numerator, we write 7 times the fourth root of 125. And in the denominator, the fourth root of 5 to the fourth is just 5. So this is our simplified answer. Okay, and the next one, 5 divided by the cubed root of 121y. So rewrite the cubed root of 121y. 121 is 11 to the second, and then times y. So the form that one takes on this one will be the cubed root of 11y to the second divided by the cubed root of 11y to the second. So I'll just write down the final answer and explain why. The numerator is just 5 times the cubed root of 11y to the second. And in the denominator, the cubed root of 11 to the second times the cubed root of 11 is the cubed root of 11 to the third, but the cubed root of 11 to the third is just 11. And then the cubed root of y times the cubed root of y to the second is y, because the cubed root of y to the third is just y. So this is our final answer on that one. Okay, on the next one, well, there's a hard way and an easy way to do this one. Notice that in the numerator, inside the square root in the numerator, we have a factor of 7. But notice that 175 is equal to 7 times 25. And we also have a common factor of m and in the numerator and denominator, and one factor of n that's common. So this time, if we write it as a single square root, square root of 7mn over 175 mn to the 7th, and then write the rational expression in lowest terms, 7 over 175 simplifies to 1 over 25. M divided by m is 1, so those cancel. And then n divided by n to the 7th is 1 over n to the 6th. And then in the numerator, the square root of 1 is 1, and in the denominator, the square root of 25 n to the 6th is 5 n to the 3rd. That's the simplified result. Okay, let's look at the next page. Solve radical equations. Okay, so on this one, the square root of 7x minus 10 equals 5. So we square both sides. The square root is by itself. The square root of 7x minus 10 squared equals 5 squared. When we square the square root of 7x minus 10, we just get 7x minus 10. And on the right-hand side, 5 squared is 25. Then solve this equation for x, add 10 to both sides, 7x equals 35, and then divide both sides by 7, x equals 5. And you could easily check that 5 is a solution. I'll leave the rest of that for you to do. On the next one, the square root of 3y minus 2 equals y minus 2. So the square root is isolated. So to solve for y, we square both sides. Square the square root of 3y minus 2. And then square y minus 2. That means y minus 2 times y minus 2. And when we square the square root of 3y minus 2, we get 3y minus 2. And y minus 2 times y minus 2 is y to the second minus 2y again, and negative 2 times negative 2 is plus 4. So we'll do a couple of things at once. We'll subtract 3y and add 2 to both sides. And on the right-hand side, we'll have y to the second, and then minus 2y minus 2y minus 3y is a total of minus 7y. And then 4 plus 2 is 6. And we can solve this by factoring. One factor is y minus 6. The other one is y minus 1. This equation down here has two solutions, y equals 6 and y equals 1. When you test at y equals 6, you'll get a true statement. But when you test y equals 1, you'll get a false statement because the right-hand side becomes negative. So y equals 6 is the only solution. Okay, a question on YouTube: is tomorrow's test to be during class? Yes, from 8 o'clock till 9 o'clock is tomorrow's test. I'll send a Zoom link today. Okay, the next one, the fourth root of 3r plus 4 equals 2. So this time we raise both sides to the fourth power because of the fourth root. And the fourth root of 3r plus 4 to the fourth is just 3r plus 4. And 2 to the fourth, 2 times 2 times 2 times 2 is 16. And then solve for r, subtract 4 from both sides, we get 3r equals 12. R is 4 because 12 divided by 3 is 4. Okay, we have a little more than 2 minutes left. Let's review the square roots of negatives. The square root of negative 36, that's the same as the square root of 36 times the square root of negative 1. The square root of 36 is 6, and the square root of negative 1 is I. The next one simplifies really nicely. We can just do this directly. The square root of 121 is 11, and the square root of negative 1 is I. So this simplifies to 11i. This one's a little more involved. The square root of 75 is the square root of 25 times the square root of 3, and then times the square root of negative 1. And then the square root of 25 is 5. 5 times the square root of 3 times I is the simplified answer. Okay, the next ones. The square root of negative 32, think of that as the square root of 32 times the square root of negative 1. The largest factor of 32 that's a perfect square is 16, so this is the square root of 16 times the square root of 2 times I. And finally, we get 4 times the square root of 2 times I. The square root of negative 45, rewrite that as the square root of positive 45 times the square root of negative 1. The largest factor of 45, that's a perfect square, is 9, so we get the square root of 9 times the square root of 5 times I. And then the final answer, the square root of 9 is 3. 3 times the square root of 5 times I. Okay, then the last one, the square root of negative 252. So that's the square root of 252 times the square root of negative 1. And the largest factor of 752, that's a perfect square, is 36. 7 times 36 is 252. So the square root of 36 times the square root of 7 times I, and then the last step, 6 times the square root of 7 times I. Okay, we're out of time. Go ahead and sign in for attendance. And as I said earlier, later today, I will send a Zoom link for test 3 that starts tomorrow, a few minutes before 8 a.m. tomorrow.